Yeah, we're really excited to have everybody here. Go ahead, and then if you want to talk or say where you're from or where you're joining us from, please do share. Not even in just the Zoom chat, we are streaming currently on YouTube, Instagram, Twitter, and a few others, I believe. Go ahead also and remember to subscribe to our YouTube channel, Magnimind Academy, where we upload all of the recording sessions that of all of these talks for you to watch them later at your convenience. Without further ado, I would like to welcome Daniel Huss, who will be presenting his talk, Build versus Buy Decisions in Data Science. At Magnimind, we strive to find speakers who can deliver talks like these, filled with the current information and the different kinds of perspectives to go along with our data science education programs. These programs are designed to build the fundamental knowledge needed for a career in data science, and whether it's refining your skills when you're already a data scientist or launching your whole career change full stack boot camps. Magnimind has something to offer, mainly on his experience in this realm allows him to give insight to many different aspects in the data science decision making. We will hear him talk mainly about this today. Graduating from San Diego, transitioned into product design later, while being a founding member of about 3 different startups along the way. We at Magnimind are extremely excited to host him, and we would like to ask you now to give your full attention to Daniel.
Awesome. Thank you, Thomas. Thomas, you were breaking up just a little bit there, but I think folks got the gist. If I'm breaking up or you can hear me, why don't you just give me a little, you can hear me in the chat? That would be lovely. Not an issue. Seems good so far, but you gotta love Zoom presentations because anything could happen. So as Thomas said, I've got a background in entrepreneurship and I've done some fun things, lifestyle businesses. I ran a company called Hot Sauce Adventure Club for years as a fun side project. But as of today, I left my jobby job to be the founder of a company called Gravity AI. It's essentially a marketplace for data science solutions, verticalized data science solutions. And my experience with starting this company and through enterprise is actually one of the reasons why I've created this presentation and why I feel moderately qualified to speak to this. So it looks like we've got a mix of data scientists and probably some, folks on the business side and product side, or just other folks that are curious about it. So a little later, I'm definitely going to go over like what I want you to get out of this discussion today. So I should start. Sadly, if it's not evident, am not a data scientist. I wish I could up my data science skills. I love stats, analytics, but just so bad in R and Python, and it's a super bummer. So I turned my attention to product management. I've been building products for 15 years, most recently with BCG Digital Ventures, which is an outsourced startup factory for large enterprise. And then I transitioned to State Street Corporation, which is one of the largest financial entities in the world. At both places, I was building true AI, not like you guys know how people say it's AI. It's not AI. It's 95% of the time, it's not AI. But I was building true AI that was actually making very interesting decisions. But I've only really been building products in the data science space for about maybe 6 years, 5.5 years. And early on in my career, working with data scientists, this is how a typical conversation might go with a data scientist. So I say, hey, we've got XYZ business problem, and we know that there's a lot of data to support this. What do you think about this? And Most data scientists I've ever worked with are total badasses. So they'd come back and they'd say, well, what's the, explain to me the business use case. What types of data do we have to support this? Just being good data scientists. And then at the end of that conversation, they'd say, I can totally build that. Of course I can build that because I'm a badass data scientist. It's just a simple Bayesian model that I'll easily deploy with Kubernetes and blah, 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 blah. And then I would say, cool, that's awesome. And then I would take that back to my leadership at the company, and I'd say something like, yeah, man, data scientist totally got it. He's going to use the Malaysian and Uber spaghetti, and we're going to have it all solved. I love that Uber spaghetti. And I think what this really illustrates, particularly because data science as opposed to software engineering is so young, is just the extent of the knowledge gap that still exists in a young field like this. And we see this knowledge gap really pervasively with business people and product people who haven't been working in the data science world very much at all. And I would say that there's still so much new stuff coming out all the time that this gap is actually widening as opposed to shrinking. Although you can make an argument that some executives and some folks are slightly getting better at this. But if you're a data scientist on the chat and you've experienced working with an individual who has a massive knowledge gap about what you do, I'd love to get just like a thumbs up or a yes while I take a sip of my beer. Yep. So I love it, 100%. Keep it 100. This knowledge gap actually leads to a lot of situations that are a combination of the business leader, whoever's working with the data scientist's fault, and kind of you guys, the data scientists, because it leads to a situation where, because of that knowledge gap, all I can do is trust my data scientist who says I can build that. And they totally can build it, because data scientists that I've encountered are badass and they can do it. And this is typically the default for most organizations, is to build it internally. Maybe with some sort of starting point from open source or somewhere else. But a lot of organizations actually have, if you're not aware, bans on utilizing open source code in production, such as State Street, my last company. You cannot use open source technologies in production. So oftentimes the default is, yep, let's build this internally. And so they do, and they decide, oh, cool, we're going to run this data science project, and we're going to try to go build this like a software development project. And no, data science is not software development. It's not at all like that. And this ends up having significant consequences. Consequences like wasted scarce resources, slower speed to market for data science, and a substantially higher risk of failure. And this is actually what is happening literally right now across large enterprise. Wasted resources. I don't know if you data scientists know this, but you're in high demand. I've seen some numbers that suggest that demand for data science talent is 4 times that of current data science supply, and getting even more so. Slower speed to market. We know that, to get a model proof of concept up and running, maybe to 80% accuracy or confidence, is really fast. We could probably pound that out in a week, but to get a true production ready model for a lot of cases can take 3 to 12 months at a minimum. And added risk of failure. There's a lot of reasons why this is the case, but in internal data science projects at large enterprise, Gartner has come out, among other companies, with estimates suggesting that 85% of these internal data science projects fail. Now, again, that's for a multitude of reasons. Maybe, not access to the right data, probably, executive shiny object syndrome, where we need this ultra powerful machine learning model to power what could have just been, simple line of code for a decision, hierarchy. I don't know. But whatever the reason is, a huge number of these are failing. So the consequences for large enterprises is actually really high. So with that, I want to help you understand the mindset, because we've got several types of individuals on this presentation. If you're a data scientist or if you're a business person, you should approach this somewhat differently. So let's take a quick second to talk about if you're a data scientist. What mindset should you be viewing this presentation in? Well, really it's, I want you to figure out how to help us. People who don't know your world, we desperately need your help as much as humanly possible. And this presentation is designed to facilitate a way to help discuss things with us. Data scientists on this call have all seen this diagram before, right? Data science being the intersection of statistics, computer science, and business. And I definitely believe this is true. I think oftentimes, though, the business portion of this Venn diagram is thought of as really understanding the business problem that's being framed by someone like myself or another person in the company. But what's kind of missing here, and I don't fully expect data scientists to have to go through all of this, because that honestly, that's a not fair ask of you. This is somebody else's job. But it's not just about understanding the business problem. It's also about understanding the context for the business and the larger picture that this fits into for that problem that we're trying to solve. This becomes extremely critical in build versus buy decisions in the organization. And if you have that context, you can help folks like myself make better decisions. So switching from the data science perspective on this presentation to the business person or product manager perspective, really, I'm trying to help you close a little bit of that knowledge gap today about what types of considerations you should have for build versus buy, and the way that I think about that. So without further ado, what is the product management mindset that we use when we're taking a look at build versus buy decisions in a data science context? Well, the first thing to understand is one of the major interesting trends that's taking place right now. And that is the concept of the commoditization of some algorithms. In the early days of, and early days, I mean, like, this isn't that long ago, of data science, I mean, a lot of stuff really had to be legitimately just built internally because there just weren't a whole lot of people doing it. Data sets weren't available, et cetera. But now what we're seeing, because of three things really, is what we call the commoditization of some of these algorithms or solutions. So new tech is certainly contributing to this. Amazon SageMaker and others, although, we all know in the data science world that AutoML is no panacea. It's not going to eliminate data science jobs anytime soon, but it certainly is making certain types of solutions like NLP, for example, much more commoditized or regularly available that perform very well. Widely available public data is another one. So, Google just released how many hundred thousands of data sets? So if you're able to get access to data, that suggests that you're able to create a fairly well-performing model. And the prevalence of available public data now means that you're just going to start seeing better performing algorithms that are publicly available. And of course, we have a very fragmented industry as far as like data science shops go, but we've got so many small data science shops who focus on either vertical solutions for specific industry or horizontal solutions across data science. Gravity AI as a marketplace, I work with a number of vendors like this. So we work with Alexandria Technologies, who has vertical NLP solutions for finance. We work with a company called Cividia that has horizontal object detection algorithms. So they focus on object detection as their core competency, and they've built a number of solutions that work extremely well in that space. So these trends are really the start to understand how to think about build versus buy decisions. Now, if we take these and put these in the context of a mindset for PMs, it's the outcomes over outputs mindset. What do we mean by that? So as a product manager, I care about outcomes. Do people like what I've built? Is it adding value to the company? Are we solving some significant problem for our users or, again, for the company as a whole? Are we generating revenue, et cetera? So those are types of metrics for outcomes. Outputs are the types of things that you measure to get to those outcomes. So outputs might be the classic project management outputs are on time, on budget, on scope. But if any of you have ever worked on a project, you know that it can be totally on time, on budget, and on scope, and totally fail. Have any of you, if you're on the chat, have any of you built something for an internal audience at a company and it was totally on time, on budget, and on scope, but then nobody used it? I'll take like just 5 seconds if that's the case for you guys. Just pop that in the chat. I certainly know I have. You have, maybe you just don't want to admit it. But we, yeah, that's a big part of it, is thinking through end to end with the products. So this is my mindset, right? Is to basically de-risk our outcomes. I don't really care how we get to those outcomes, to be honest. If we have 10 features versus 8 features of a certain product, or if we develop it internally versus externally, it doesn't really matter for me as long as I'm achieving the overall outcome that we're trying to do. So really, my entire role is to de-risk those outcomes. And we have a lot of assumptions that come with each one of those. And we view those assumptions through several lenses. So if you understand the core assumptions for the product that you're trying to build, and as someone just mentioned in the chat, it's really like end-to-end understanding, then you understand the context in which to make a build versus buy decision. So what are those 3 lenses that I view the world from? And as a data scientist, if you can start to see the world the way that I see it through these lenses, we can make better decisions here. And as business professionals, if you can start adopting these lenses, you're going to be better enabled to make these decisions as well. And that's really good product management: desirability, viability, and feasibility. Does this add to my ultimate end user's experience? So do people want it? Do they care? I can think of great examples of fantastic pieces of technology that people just didn't want. If you own a Segway right now on this chat, I'd love to hear about it, but I'm guessing you probably don't own a Segway. Segway is a cool piece of technology, don't get me wrong, but it really wasn't solving a big part of a desirability problem. Segway imagined a situation where they would have the entire world riding around on these things on sidewalks, and you just don't see that. They ended up finding a market. They found a market in what? Security officers, tours, city tours, etc. But the general desirability for a very cool piece of technology probably just wasn't there. Deep apologies if there's anyone on this that was part of building Segway. Viability. Is this providing enough value to the business? Do we have a business model that can sustain what we're doing? And by the way, I'm going to go into detail on how this ties back to data science decisions on subsequent slides. But an example of where we had a totally desirable product, but there was a viability failure, I think a great example is WeWork at the moment. It's a very desirable product. I have a WeWork membership myself, although obviously I haven't gone in a little while for obvious reasons. But someone didn't look very hard at the business model right now and say, oh my gosh, we're losing a ridiculous amount of money. Maybe we need to tweak our viability. So that's a failure of viability in my mind. And finally, feasibility. With our company's skills, limitations, such as like compliance, regulations, do we even have the ability to do this? Does the technology even exist to do this? I think a great example of a product that whose value proposition was highly desirable, there was a total business model for it, but kind of was ahead of its time from a technology standpoint, and kind of failed in that regard, was the early Apple Newton. Drop me a yes in the chat if any of you had an early Apple Newton. But it had this cool stylus, and now the technology totally exists. Obviously, we use it every day on our smartphones and iPads. But the Apple Newton just didn't work well. You could draw on it and write messages with your stylus, and it was supposed to recognize your handwriting. And the problem is it just didn't work particularly well. The value proposition is highly desirable, but they just didn't execute on it. So let's do a little bit of a deep dive in each one of these as it relates to data science and how we need to be thinking about those build versus buy decisions. Thanks for coming, Rod. All right, desirability. So there's three real core aspects when making a decision here for build versus buy. One, what is our required level of accuracy or confidence for this algorithm, for this model? If you can get away with just a 80% model, that's going to be very different than if you need to train something up so that it's 99% accurate. That's going to affect your decision about how you go to the market with it. Perhaps you can find something off the shelf that is 80% accurate, right? Next would be error handling. This is tightly related to accuracy and confidence, but what happens if the algorithm has an error or can't assign, it's outside of its confidence level or accuracy level? There's a great YouTube channel, it's Tom Scott, Things You May Not Know, where he talks about how he, embarrassingly, I can't even believe he talked about this. He talks about how he had to get an STD test in the UK. And when your test is positive, you call a lineup, and when your test is positive, it directs you to a person, so you get bad news from a person. But when your test is negative, it just directs you to an automated voice that says, "You're fine, you're in the clear." And he hopped on the call, and for 10 agonizing minutes, whatever algorithm behind the scenes was trying to make a decision about where to route him. So he sat on the call just in terrified, and finally it routed him to a live person. So he's like, "Oh, of course. Oh no, I caught something terrible." But when he got on the line, the person says, "Oh no, you're in the clear." So Tom Scott says, "Why did it route me to you?" And she says, "Oh, I don't know. It just does it sometimes." So that's a situation where error handling for our end user would be fairly important when the whatever model's in place is having difficulty making a proper decision. And finally, explainability and trust. Obviously, this is kind of a big, hot topic right now, but this is also going to, if you have to have something that's super, super explainable, this might affect your decision for build versus buy. So that brings me to, what does this mean in real life? How does this actually apply versus just Tom Scott? It's real life time. So for desirability, here's a couple examples, and feel free to blow me up in the chat because some of these aren't the most accurate from a data science perspective, but just give it to me, So let's say you have a model that, using the 80% benchmark. Is 80% accuracy in this model okay? Well, something like voice recognition in a smart home speaker, yeah, probably is okay. In fact, I would argue that for people of Scottish heritage who have an accent, they're dealing with maybe 20% accuracy and probably still buying these things. If you've ever seen those funny YouTube videos of Scots trying to talk to their Alexas, I feel bad for them, but they still have them. So the consequences are fairly low. So maybe this is an area where you can source from a third party the voice recognition software because you don't really need it. If you've got that margin of error, it's fine. The consequences are fairly low. And indeed, that's kind of what we saw with Amazon. I'm sure they built some proprietary stuff internally on this, but I definitely know that they either acquired or sourced from third parties lots of their voice recognition. And I mean, like stuff like Dragon Software has been around for a long time, right? So buy it, take a look. This is a great opportunity where go to a third party. 80% accuracy, okay. I recently moved back to San Diego from New York, and I had to buy a car. I bought my Tesla. So that autopilot feature on the highway, 80% is not okay for me for accuracy, because the consequences are pretty darn high if something goes wrong. So this might be a situation where you need to spend a lot more time building stuff internally to make sure that your model is going to be substantially well performing enough in order to satisfy customer needs. Now, I think Tesla does a very good job of error handling when it does make a mistake. It definitely beeps at me that I got to grab the wheel really fast, but I wouldn't argue that that's a great user experience. It's just a good way of handling errors. Here's an example for NLP in error handling. We have a client, Trip Scout, who has a location or a travel app. We have an NLP that detects geography and text pretty well. Not that great. It's maybe 75% accurate, but there's kind of the human in the loop process that makes it so that, one, there's just not that big of a consequence if it doesn't recognize the geography perfectly, and two, they can basically route this through another API to a human or to a database to check whether or not it's picking it up. So this is a great example of something where, from a user perspective, you should buy it. And finally, explainability. While I was at State Street, I built a app that ranked and sorted news and tied it back to your portfolio holdings and scored it, and then made intelligent decisions about which metrics were most important for you to look at based on that news. We heard directly from clients that we need to know what goes into that score, otherwise we're not going to trust it. So we actually had to go back and slightly redesign our approach to how we thought about that scoring methodology to make it explainable, and then design an element of the product around that, which we called score transparency. So let's jump on to viability. So viability, again, is this providing value to the business? Is there a good model? Is there efficiency around this? Does this make just good business sense? So one aspect of that is this type of algorithm commoditized, or is this providing a true competitive advantage for my company? Is this going to be something really proprietary to us? In that tool that I built at State Street, we had about 22 different models in the pipeline to ultimately make this thing work, including a spam filter to block out news. Spam isn't proprietary, it's totally solved. It's super commoditized. That's not something that you should build. So, you should spend your time, since you're a limited resource as a data scientist, building the really proprietary stuff. Spam is something that you should probably think about buying. Similarly, maybe other NLP solutions. Cost and opportunity cost are huge. This goes back to, again, data scientists as a limited resource currently, and the fact that building production-ready models takes 3 to 12 months. Are you better suited building something that you can get somewhat off the shelf that might not be proprietary, or are you better suited working with your company's super proprietary data that there's definitely nothing out there on? So as a data scientist, you can help me make that decision, because you're probably going to know what is going to perform off the shelf better than me. And as a business person, you need to have this as a consideration for you, and know what types of things are available off the shelf, and just the length and time and effort it takes and opportunity cost for developing models. And finally, is this part of a larger corporate strategy? Like, are you trying to build a center of excellence around NLP? then maybe you do want to build something like a name entity recognition algorithm that is otherwise moderately commoditized. These are the major viability types of assumptions and considerations that we have to think about in real life time. So what does this mean? So here's a great example. OCR. OCR stands for, if you don't know, optical character recognition. OCR has been around for a very, very long time. If you are a bank and you are interested in allowing your customers to do mobile deposits of their checks by taking a picture with their smartphone, you should not build check OCR internally. Yet I totally know companies that are building OCR for checks internally right now, despite the fact that there are totally well-performing solutions out there that work extremely well. This has been around a long time. There's tons of publicly available data on images of checks. This is not something that you should build internally. Cool. And finally, the feasibility category. So feasibility, again, is should we do this? Do we have a right to play in this space? The resources, capabilities. So first, do we have the right skills and talent? I think that, and I'd love, again, to hear from the data scientists on this, data science as a title, data scientist, is slowly going to morph or go away. I think we're going to start seeing more titles around specific types of data scientists that need hiring. I worked with an absolutely brilliant data scientist named Abhishek. Abhishek kicks all sorts of ass. But Abhishek right now is being tasked at his current company to build not OCR for checks, but do OCR. And he has not done prior to this OCR. So it's not saying that he can't do this or doesn't have the education to do this, but he doesn't have prior experience doing OCR. Should he have to do this? I don't know. That's a question of what OCR they're building. Is it is it viable? A part of the viable? Is it part of their larger corporate strategy? But do we have the talent for that? Do you even have data scientists in house that could do this kind of thing? Next would be security and compliance considerations. If there are third-party solutions that work really well, I think there were some folks from Intel, and maybe I even saw someone from IBM. I know a lot of cloud solutions out there exist. Well, if you're a company like State Street, you're not sending your data to the cloud. You're just not doing it. If you're a healthcare organization, you are not sending your data to some other third party's cloud environment. So that's obviously a big compliance risk or security risk that they have to take into consideration, right or wrong. We're not arguing whether it's right or wrong, but that's the reality of the business situation. And speed to market. Is this, again, something that is going to take considerable amounts of time for us to build internally? Or can we get something off the shelf that's going to, again, satisfy that user need from Desirability very, very fast? So a couple examples here, again, was I worked with a data scientist who we at State Street was trying to build. State Street was trying to build their own name entity recognition internally. One of the data scientists on the team was absolutely brilliant, but had never worked really in the NLP space. So it took a lot of time to catch up on that. They did too, and they did a great job on it. But the ability to get something like name entity recognition off the shelf, it's just so available now that it was probably a poor decision to build that internally. So this is something that, as an example, something that you should buy. And data scientists help us make these types of decisions as business owners and product managers, because a lot of folks who aren't in the space probably don't know this. If you're working with an executive or a business person and you go, yeah, we need NER, and they go, awesome. And you go, cool, I guess I'll go build that. Tell them, hey, there might be something that we could go source. Help us make those good decisions. So I think I'm getting pretty close to time. finding the right balance between all three of these buckets, as illustrated by my cheesy expanding and contracting animation, is really kind of the key to finding a successful data science project. And that's our sweet spot that we're looking for. So if you, as data scientists, can help us make better decisions within the context of these three categories, man, it's just going to be better for you and for me. And then as business folks, looking at those considerations and knowing that some of this stuff may be better for you to go source from a third party, like some of the examples that we saw, is going to help you have a better conversation, obviously, with your team as well. So with that, I'm happy to kind of take any questions. Would love to hear your guys' thoughts. Feel free to just pop those into the chat. Show you the last slide, this slide here. Oh, yes. Sorry, I guess that does kind of disappear. There we are. Yeah, feel free to reach out to me. Yeah, it's an important UX fix. Yeah, feel free to shoot me an email. You know, this isn't about gravity, this presentation, but if you're a data scientist who wants to monetize their solution through something like a marketplace, we literally pay data scientists thousands of dollars a month currently. If you're an organization who needs help getting some of these solutions, that's what we built this for. And certainly just send me a note with other questions, by all means. Other questions? Yeah, how do a data scientist's job look after 5 years? So this is a really interesting topic because I think if you were to go on like places like LinkedIn right now, you would see posts titled "The Death of the Data Scientist," you know, and they're mostly talking about things like AutoML and other technologies that are coming out that make this process easier. And the data scientist job is not going away. The critical thinking data scientist who is connecting real business problems back to data science challenges is never going away. That's a critical function that only they can play. You know, and helping us understand the data science concepts. You know, is this a Bayesian model? Is this, you know, whatever? That's not going away. What is going to start to, I predict, change again is you're going to see either vertical specialization in fields or perhaps even horizontal specialization. That's already kind of happening because you're going to, because of the way that the industry is set up and it's still fairly new, you just get basically like full stack data scientists for everything. But you know, if you were to hire a software engineer, you could still hire a full stack software engineer. But oftentimes you might say, hey, we work in Java. You know, do you have experience in Java? And you know, that's obviously important from an engineering standpoint to know if like your entire platform is built in that. Similarly, I don't think you're going to see as much of that like for specific data science languages like R or Julia or Python or whatever, but you are going to see, hey, we really, you know, have a large focus on natural language processing or object detection or whatever that is. And I think that the profession is going to start shifting to those types of more horizontal solutions. Are application performance and scalability kind of considerations required for build versus buy? Totally. Yeah, I didn't really cover a whole lot of that. I think that's a big part of the feasibility and a little bit of the viability part of my considerations. Is something that we're going to be working with, you know, if we're going to go source this from a third party, is it going to be able to scale with us? You know, is kind of a big core question. Also, you know, a big part of any model is model maintenance. And are we going to be able to maintain this if we're able to source it, or is this partner going to be able to assist us in maintaining that? So a huge part of kind of the feasibility of what we're focusing on is understanding how things might scale with us as we grow that product out. Also, sheer, as you mentioned, performance. You can certainly buy some things off the shelf, and they're going to take, if they take forever to run, you might run into a situation. So you might need to actually focus on building something that was otherwise commoditized internally just to get it to perform better. Any visualizations of my solution I can share? By my solution, I'm assuming you mean the company Gravity AI. Feel free to go to gravity-ai.com and you can look at some of the solutions that we have listed on the site. We're still a fairly young startup, so we're working to grow that list. But you can also check out demos at our YouTube channel of the site in action. And again, if you email me, I'm more than happy to give you a demo myself. I assume that's what you meant. Vijay, if you meant something else, by all means, please ask away. I hope you guys are also enjoying beer, by the way. Who designed your slides? Very nice and interactive. PowerPoint? Not the point of my call, is as you pointed out, but thank you. I super appreciate that, because this guy designed these slides. I've done enough now pitches to VCs that I'm like a slide master. So I really appreciate that feedback. You talked about tools that should not be built in-house. What are the most common solutions that should be built in-house? That was a Facebook question that came in. So here are I'll give you the situation, maybe not tools, but I will give you the situation that you should definitely build something in-house. And by in-house, I mean, you could still maybe use like a third-party consulting company to help you build it in-house. That's not what I mean here. I mean like a custom solution that you're building internally, not buying a prepackaged solution. So that situation is you have extremely proprietary data that nobody else has. And at that point, you're very unlikely to find something that is going to work even remotely well in your solution. There may be things that you can use in the open source community to get you started, but certainly you're not going to be sending that data outside of your organization, because that data is the new oil, right? It's extremely valuable, so you're not going to risk sending it to a cloud provider. And you're probably just not going to find a solution that's going to work on that super proprietary data. It's going to take a lot of true data science, the science side of things, testing, experimentation to get something to work. And that falls right in line with it being extremely proprietary, right? If this is part of your IP, your actual true intellectual property of something that you're building, again, most likely you're going to want to build that internally. In the case of State Street, with that huge string of models, what was proprietary for us was the way that we put those together, mostly to get the output. And then, of those, maybe only 6 were truly proprietary in-house models that we created that made the engine work. But again, things like spam, NLP and NER that we were using were stuff that we just knew we shouldn't build internally when we ended up going and sourcing. 2 questions here. What do you think is the role of companies like H2O or AutoML in data science AI space? Yeah, I love H2O. I think they're an awesome company. Obviously, they're dominating the Kaggle boards right now. When I was talking about the role of the data scientist, I mean, something like AutoML is not going to replace the data scientist, right? Like it's just, it's definitely going to make certain types of solutions more commoditized. And that's what we're seeing with, things like image recognition and again, NLP. And there's certainly other examples as well. If you guys have any examples, I'd love for you to share them in the chat. But I don't think that that's going to certainly affect the way that data scientists operate. If anything, it's maybe just going to make their lives a little bit easier and be seen as an additional tool. Some of these solutions are going to continue to grow and expand and make other parts of data science more accessible. You hear a lot of companies throw around the term democratizing AI, and I think that's great. You're going to be able to, companies that can't afford a data science team or can't get access to data scientists are going to be able to start using some of these solutions when they might not otherwise be able to. I work with a lot of like small hedge funds and banks who don't have data scientists and can't, again, there's a big data scientist shortage. So these types of solutions offer them a possible way to participate in this world. A question from Jay: should we treat desirability, viability, and feasibility with equal weight? That's a fantastic question. Depending on the type of product manager that you ask, and depending on who you ask in an organization, you're going to get a different answer. So if you ask an engineer, they're going to tell you that feasibility is probably the most important. If you ask a business exec, they're going to tell you what? Viability. Like, it's all about the dollars, right? Revenue. But the correct answer, and I'm just going to go ahead and say the correct answer, is desirability. If people don't want it, why are you building it? Desirability is super, super important when considering these types of decisions. So again, if you're making a build versus buy decision in the data science context, and you know that you have to have certain parameters in this for example, the explainability, like what I was building at State Street, that might be something that you build in-house. If there's parts of your solution that aren't going to affect the desirability or perhaps even enhance it, I think that's definitely where you should spend your weight. And the reason that I say that's the correct answer is because for so long, organizations have put so much emphasis on viability. They start with that. We have a solution looking for a problem, right? I'm sure folks on this can relate to that. And that's a really tough way to go build a product. You bet. Very welcome.
All right. If there aren't any more questions, I guess.
Thomas, you're breaking up just a little bit again.
I don't know what's going on with my Wi-Fi today. This is awful. Thank you all for attending the talk, and thank you, Daniel, for your time. We hold these talks to hopefully help people further their learning, and if you've come here, you've all done that today. Oh, there is one more question. Okay, I'll let you answer that.
What is the likelihood that modules, models, algorithms will all need to be certified for privacy, such as something like GDPR? Obviously, California just passed some privacy laws. I think this ties back pretty heavily into, both the explainability piece, the trust piece, what happens with PII. The models themselves, I mean, they don't really contain data, right? I mean, they've been trained on data. So this is actually a fascinating question. This is happening in the copyright space as well, or I'm sorry, the patent space as well. The patent office just put out a big survey on how it should treat, exhaust from models being trained or, being retrained. In the privacy space is the ancillary capability of an algorithm that's been trained on your data infringing on your privacy. I mean, that's a big part of, I think, the discussion that's taking place right now. I think it's very unlikely that we will see models and algorithms themselves that have been trained on data from large, publicly available data sets of our interactions needing to go through something like a GDPR, What will continue to be really relevant, though, is how you're running data through those models ultimately. And, is that data, how are we treating that data? But if there's other opinions on that, I'd love to hear that. I just can't see how you would even begin to set up a system to, think about training the models. Oh God, this is so meaty. These are such meaty, good questions. So yeah, related note, who will be responsible for indemnifying the solution when outside models are incorporated? This is another reason that my company exists and why open source technology is that a lot of the large companies like State Street are banned from production. Because if you've ever gone through contracting with State Street or a company like it, it takes 18 months and they're going to demand unlimited indemnification if something on that goes wrong. It's a major concern. That's for sure. And there's actually companies right now out there. I think it's called Black Duck. If you guys remember, and I'm wrong on that, let me know. But Black Duck actually goes and tracks down, if people are using open source code in their models and where that came from. Now, that's not just for indemnity purposes, but that's also to make sure that they're not using code that was created by an embargoed country or something like that for compliance reasons. I think it's a fascinating question. I don't have a good straight answer for you, but I do think that models like my company, and models like data science shops, we're starting to see the evolution of the business side of this industry. So you actually have parties that could be responsible for this now. Such meaty, good questions. Oh, good Lord. I'm glad I have opinions on them.
Yeah, all right. I bet. We got one more.
So can Gravity AI afford to offer 500 million indemnification if a customer demanded? You'd have to ask my underwriters what level we're willing to go and indemnify. We've got an interesting way of handling that. We do depending on the enterprise, we can do a little bit of a case-by-case basis. We as Gravity AI in a marketplace are facilitating a transaction. So in many ways, we are not necessarily responsible for their use of that code in end production. That said, we have a SLA just like any other company in the way that you would use us. So we would certainly, with certain enterprises, are forced to participate in that. So yeah, that's very real.
All right. Well, thank you for answering all these questions. I know it was a bit of a marathon for the question segment. Thank you for everyone for attending your time. If you haven't already done so, please subscribe to our YouTube channel. You'll be able to find the talk that Daniel just gave if you joined late, and you'll be able to catch up or look at any other talks that we've currently had. Our next talk will be on May 13th called Trends in AI. Thank you everyone for coming, and have a good day.
You've all been awesome. Thank you so much.
Thank you.